In this section, we're going to discuss concentrations of solutions and how chemists will express these concentrations of the solutions we're going to analyze. So, solutions have a varying degree of concentration, from being very strong to very weak. The greater the amount of solute that dissolves, the more concentrated a solution is. So we need to now come up with a unit that's going to allow us to express how concentrated or how weak a particular solution is. And a chemist expresses concentration in units of molarity. So molarity is our concentration unit, and molarity is abbreviated with a capital M. And the units that we're going to use are moles of solute per liter of solution. So we can look at these, and now we can do some example problems using this unit, which is molarity. So the first example we're going to look at is to calculate the concentration of a solution containing 2.8 grams of potassium hydroxide, which is KOH, dissolved in 250.0 milliliters of water. So in order to set this up, we need to know, if we're calculating concentration, chemists have that in terms of molarity, and that's moles of solute per liter of solution. So there's two things that we need to do here. Step one is going to be to convert the grams of potassium hydroxide to moles of potassium hydroxide. Then the second step is going to be to convert 250.0 milliliters to liters. Once we do each of those, we can take the moles, divide them by liters, and get our concentration. So we can take 2.8 grams of potassium hydroxide, and using the periodic table, we can show that 1 mole of potassium hydroxide is equal to 56.1 grams. If we convert that over to moles, we get 0.050 moles of potassium hydroxide. So that is our first calculation, and now we need to perform our second calculation, which would be to convert the 250.0 milliliters over to liters. We know that there are 1,000 milliliters in 1 liter, which gives us 0.2500 liters. If we want to calculate the molarity, it's going to be moles of the solute, which in this case is potassium hydroxide, divided by liters of solution. And in this case, we have 0.050 moles divided by 0.2500 liters. So this is going to give us a concentration of 0.20 molar potassium hydroxide. So this is a way that we can calculate a concentration given the grams of a particular substance that dissolve in a specific volume of water. So to set the stage for the next sections that we're going to discuss, we can talk about interconverting molarity, moles, and volume. And if we look at this, we know that the molarity, or the concentration, is equal to moles divided by liters. So there are 3 different units that we're going to look at, and if we're given, or if you have 2 out of these 3 quantities, you can calculate the other. So if you have the amount of moles that dissolve per liters of solution, you can calculate the molarity. We can rearrange each of these, we can rearrange this equation here to determine each of these quantities. So if we want to determine moles, that's going to be the molarity times the volume. And if we wanted to calculate the volume, we can say that that's going to equal the moles divided by the concentration. Okay, so we can interconvert between each of these quantities, and that's exactly what we're going to do throughout the remainder of this chapter when we're dealing with these calculations.